Hey there, petrolheads. Today we're diving deep, not into a tank of high-octane fuel, but into the fascinating world of submarine power. Buckle up, because this journey is going to be as thrilling as a high-speed race. Imagine this, a vessel, hundreds of feet long, cruising silently beneath the waves for months. No pit stops, no refueling, just pure, stealthy power. It's like a marathon runner who never needs to stop for water. These submarines are marvels of modern engineering, designed to operate in the most challenging conditions. No pit stops, no refueling, just pure, stealthy power. That's the magic of nuclear-powered submarines. They harness the incredible energy of nuclear reactions to stay submerged and undetected for extended periods. Now, you might be thinking, nuclear reactors in a submarine? Isn't that, a bit risky? And yeah, it's a fair question. But trust me, the engineering behind it is nothing short of brilliant. These reactors are designed with multiple safety systems to ensure they operate flawlessly. But trust me, the engineering behind it is nothing short of brilliant. It's a delicate dance of physics, engineering, and a touch of daredevil spirit. The precision and expertise required are mind-boggling. It's a delicate dance of physics, engineering, and a touch of daredevil spirit. These underwater behemoths are crucial for naval defense. They patrol the world's oceans, acting as silent guardians, always ready to defend. Their presence alone is a powerful deterrent. But what makes them so special? What gives them this edge? Why are nuclear reactors the go-to choice for these underwater marvels? Let's find out. Stay tuned as we delve deeper into the technology and innovation that powers these silent guardians of the deep. Why are nuclear reactors the go-to choice for these underwater marvels? Let's find out. Join us as we explore the intricate details and groundbreaking advancements that make nuclear-powered submarines the pinnacle of naval engineering. Before we unleash the power of the atom, let's understand the challenges submarines face in the deep blue sea. Submarines, unlike their surface counterparts, can't just pop up for air or a quick refuel. They operate in a world where surfacing is a luxury they can't afford. They operate in a hostile, unforgiving environment, hidden beneath tons of water pressure. The deeper they go, the more intense the pressure becomes, making it a constant battle against the elements. Traditional submarines relying on diesel-electric engines face severe limitations. These engines are not only noisy, but also require frequent surfacing. They need to surface regularly to run their diesel engines and recharge their batteries. This process is time-consuming and risky. Not exactly ideal when stealth is your middle name, right? The need to surface makes them vulnerable to detection. This need for surfacing compromises their stealth and limits their range and endurance. It's like trying to sneak around while constantly having to come up for air. Imagine holding your breath every few minutes. Not exactly ideal for a long swim, is it? This constant need for air severely hampers their operational capabilities. That's where nuclear power comes in. It revolutionizes the way submarines operate. It's like swapping that gasping for air routine for a deep-sea diver's rebreather. With nuclear power, submarines can stay submerged for extended periods without the need to surface. Nuclear power provides a continuous, long-lasting energy source, allowing submarines to stay submerged for months. This not only enhances their stealth, but also significantly extends their operational range and endurance, making them formidable underwater vessels. Now let's talk about the game-changer nuclear power. It's all about harnessing the immense energy stored within the atom. Think of it as the ultimate energy drink for submarines, providing a continuous, powerful punch. But hold on, don't imagine a miniature sun blazing away inside the submarine. That's not quite how it works. Nuclear reactors in submarines are carefully controlled to release energy slowly and steadily. Think of it as a controlled burn rather than an explosion. This controlled release of energy is the key. It allows nuclear submarines to operate at high speeds for extended periods without the need for refueling. Talk about a strategic advantage. Section 5, a chain reaction of energy, fission, and its power. Now, splitting just one atom wouldn't really power a light bulb, let alone a submarine. That's where the chain reaction comes in. Picture this. You hit one domino and it sets off a whole cascade, right? In the reactor core, The splitting of one uranium atom releases neutrons. These neutrons then go on to strike other uranium atoms, causing them to split as well. This creates a chain reaction, a continuous release of heat. Think of it as a self-sustaining fire. As long as you have fuel, uranium, and control the reaction, the heat keeps coming. This continuous heat generation is what gives nuclear submarines their incredible endurance. Section 6, from heat to propulsion, generating thrust. So we've got all this heat from the reactor, but how do we actually make the submarine move? This is where things get really interesting. The heat generated in the reactor core is used to boil water into high-pressure steam. This steam then drives turbines, just like in a power plant. These turbines are connected to generators, which produce electricity to power the submarine systems, including the propulsion system. The steam, after turning the turbines, is cooled down and condensed back into water, forming a closed loop. The electricity generated powers a giant electric motor, which in turn spins the submarine's propeller, pushing it through the water. It's like a massive underwater electric car fueled by atoms. Section 7, the Virginia class, a nuclear-powered apex predator. Now let's talk about the rock stars of the submarine world. The Virginia-class submarines, these are the pinnacle of modern submarine technology, and guess what? They're nuclear-powered. These underwater beasts are packed with cutting-edge technology. We're talking advanced sonar systems that can detect a whisper from miles away, sophisticated missile systems that can deliver a real punch, and of course the crown jewel, their nuclear reactors. These reactors give the Virginia-class submarines unmatched endurance. They can stay submerged for months, prowling the depths without needing to surface. That's longer than some people go without a shower. Section 8, a world of submarines, comparing nuclear and conventional. Now, not all submarines are created equal. There are different classes, different sizes, and of course, different power sources. Conventional submarines powered by diesel-electric engines are more common. They're cheaper to build and operate, but come with those pesky limitations we talked about earlier. Nuclear submarines, on the other hand, are the thoroughbreds of the underwater world. They're more expensive to build, but their endurance, speed, and stealth capabilities make them worth every penny. Imagine it like this. A diesel-electric submarine is like a family hatchback. Practical for short trips, but not ideal for a transcontinental road trip. A nuclear submarine, however, is like a high-performance sports car, built for speed, endurance, and a touch of look at me. Section 9, the advantages, why nuclear power reigns supreme. So why are nuclear reactors such a big deal for submarines? What makes them stand out in the vast ocean of naval technology? Well, let me break it down for you. It's not just about the power, it's about the myriad of benefits that come with it. Firstly, it's all about endurance. Nuclear submarines can stay submerged and operational for incredibly long periods. Nuclear submarines can operate independently for months, only limited by their food supply and maybe the sanity of the crew. This means they can undertake long missions without the need to resurface. This gives them a massive strategic advantage, allowing them to patrol vast areas of the ocean without needing to surface. They can cover more ground and stay hidden from enemy eyes. Secondly, stealth is the name of the game in the submarine world. The quieter a submarine, the harder it is to detect. Nuclear submarines are incredibly quiet, making them extremely difficult to detect. Their stealth capabilities are unmatched, allowing them to move undetected. They can slip in and out of enemy territory like shadows in the night. This ability to remain unseen is crucial for both offensive and defensive operations. Finally, nuclear submarines pack a punch. They are not just silent hunters, they are also heavily armed. They can carry a variety of weapons, including torpedoes and missiles, making them formidable opponents in any naval conflict. Their firepower ensures they can defend themselves and strike when necessary. Section 10, Conclusion, the Future of Submarines. So there you have it, petrol heads. Nuclear power has revolutionized submarine technology, transforming these underwater vessels into stealthy, powerful, and virtually unstoppable forces. As technology advances, we can expect to see even more sophisticated nuclear submarines patrolling the world's oceans, acting as silent guardians of national security. Nuclear submarines are a testament to human ingenuity, a delicate balance of power and control, all wrapped up in a sleek, submerged package. Section 11, Call to Action. Dive deeper into the world of submarines and uncover hidden secrets. If you've enjoyed this deep dive into the world of submarine power, give this video a big thumbs up and share it. And don't forget to subscribe to the channel for more fascinating explorations of engineering marvels and innovations. Got any questions about nuclear submarines or any other engineering feats? Drop them in the comments below, and I'll do my best to answer them as soon as possible.